Welcome back, everyone, to the Deep Dive. Ready for another deep dive with us?
Always excited to dive in.
All right, so today, we're going to tackle a question that could totally change how we search for aliens.
Yeah.
You know?
Oh, yeah.
Like, we always think about aliens being on planets, right?
Yeah, it's kind of the go-to.
But what if that's, totally the wrong way to think about it? What if life doesn't need a planet?
Well, that's the whole premise of this research from astrobiology that we're looking at today. It really challenges us to think outside the planet box.
So how could that even work? I mean, we send astronauts to the space station, but they definitely need constant supplies from Earth.
Right, but we're talking about something potentially way simpler, like basic life forms or even just like microbial colonies hanging out in space.
So not little green men, more like little green microbes.
Exactly. And there's already proof that life can survive in space. Think about those tardigrades.
Oh, yeah. Those microscopic animals that can survive in a vacuum.
Exactly. They're like the ultimate survivors.
But surviving is one thing. Thriving is another story. What are the biggest challenges for life without a planet to protect it?
Well, first off, there's that pressure difference. Imagine the pressure inside a living thing versus the vacuum of space.
Whoa, yeah, like the difference between here and the deepest part of the ocean.
Even more extreme. But the researchers think a space-based life form could create a membrane or a shell, kind of like some seaweed here on Earth, that have air pockets to deal with pressure changes.
So it's like a little self-contained atmosphere.
Exactly.
That's wild. But what about the temperature? Space can be scorching hot or freezing cold.
Yeah, good point. But nature has some pretty cool examples of temperature regulation, like the Saharan silver ant.
Okay, I've never heard of that.
It can handle those crazy desert temperatures by reflecting and absorbing specific wavelengths of light, basically creating its own little climate bubble.
So you're saying a space-based life form could do something similar?
That's the idea. The researchers proposed that a floating colony could use a kind of similar method. They envision a thin, hard, and transparent shell that regulates temperature, like a natural greenhouse effect without needing an atmosphere.
Okay, starting to see how this could work. But what about all the stuff that life needs to survive? Like oxygen, carbon, things like that. Planets use gravity to hold on to those things. How could something floating in space keep from losing those vital elements?
That's the problem of volatile loss, and it's a big one. Imagine a balloon slowly leaking air. Eventually, it just deflates. A space habitat would face a similar issue with lightweight elements escaping.
So how do they stop that from happening?
Well, they could start with a resource-rich base, like an asteroid packed with the elements life needs. And then they'd need a super efficient closed-loop system to recycle everything and minimize loss.
Like a totally self-sufficient space oasis. But space is brutal?
Yeah.
What about radiation?
True, but radiation might not be a deal breaker. Microbes on Earth have evolved to survive in some crazy high radiation environments. Think of those microbes living in nuclear waste, or even those early life forms on Earth that dealt with way more radiation than we have today.
Life is seriously tough.
It finds a way.
So we've got pressure, temperature, and radiation covered. But how would they get energy and nutrients? Photosynthesis needs sunlight, and everything needs building blocks to grow. Would there be enough sunlight out there?
Well, getting enough sunlight isn't as big a problem as you might think. Even way out in the outer solar system, there's plenty of sunlight. More than enough for some types of algae that live under the Arctic ice.
Wow, and for nutrients.
Asteroids and comets are full of the stuff life needs. A space colony can mine those resources and then recycle them forever.
So they'd need a crazy efficient recycling system, almost like a mini version of Earth's natural cycles.
You got it.
Yeah.
And that's where the researchers think specialized organisms could come in. A closed-loop ecosystem in space would need organisms to break down waste and keep things balanced.
This is mind-blowing. Pressure-regulating seaweed super ants that control their own temperature radiation-resistant microbes, and the possibility of a closed-loop ecosystem in space. Amazing to think that all these things we see on Earth could help us figure out how to make life in space not just possible, but thriving.
Right. It makes you wonder if we've been looking for aliens in all the wrong places. Maybe life doesn't need a planet at all.
This is already so interesting, and we're just getting started.
Really makes you think, doesn't it? Like all this time searching for planets that look like Earth.
Yeah.
But what if we've been missing entire ecosystems just because they're totally different from what we expect?
So if they're so different, how would we even find these free-floating life forms? They'd be pretty hard to spot just drifting through space, right?
Well, that's where things get really interesting. The researchers suggest looking for something called a vegetation red edge.
A red edge.
Oh.
Okay, you got to explain that one.
Think about how plants use sunlight for photosynthesis. They absorb most of the visible light, but they reflect a lot of near-infrared light. That creates a sharp drop in reflectance, like an edge that we can see even from space.
So if we found this red edge coming from something out in space, not on a planet, that could mean there's life there using sunlight for energy.
Exactly.
Yeah.
It'd be a strong sign that something's doing photosynthesis just like plants do here. And remember, the researchers think these biohabitats would have to be at least a little bit transparent to let the sunlight in for those photosynthetic organisms.
So it's like a cosmic beacon, a sign of life in the most unexpected places. That totally changes the game for finding aliens.
It really does. We could be overlooking entire ecosystems because we haven't been looking for the right signs.
Mind-blowing stuff.
Yeah.
Okay, let's switch gears for a minute and talk about what this means for us humans exploring space. You mentioned bioengineered habitats earlier. Are you saying we could actually build something like these free-floating colonies?
Yeah, it's definitely possible. We can figure out how these theoretical life forms deal with the challenges of living in space, the pressure, the temperature extremes, the radiation, the need for closed-loop systems. We could use that knowledge to create habitats for ourselves that can support life.
So like growing our own spaceship out of living stuff sounds like science fiction. But could we really do that?
It's more realistic than you might think. We already use bio-based materials for buildings and other things. And with all the progress in synthetic biology, we're learning how to design organisms with specific abilities. Like, imagine creating organisms that could make oxygen recycle waste or even repair damage to a structure.
So instead of those sterile metal boxes we use, now we could have living, breathing ecosystems that grow and adapt and repair themselves. That would make space travel so much more sustainable.
Exactly. It'd be a whole new way of thinking about space exploration, moving from temporary outposts to self-sufficient colonies.
And it all comes back to this simple question. Does alien life need a planet? By questioning our assumptions and exploring all the possibilities, we're opening ourselves up to a whole universe of potential discoveries, both for alien life and for our own future in space.
Absolutely. And who knows what other incredible discoveries are out there just waiting to be found.
This has been such an amazing look at the potential for life beyond Earth. We've learned that our search might be too limited and that life might be way more adaptable than we ever thought. This is seriously making me rethink everything I thought I knew about the universe and life and all that.
Yeah, it's a real paradigm shift, isn't it? Instead of looking for planets that look like Earth, maybe we need to broaden our search.
So as we wrap up this deep dive, what are the big takeaways you hope our listeners are thinking about?
I think the biggest thing is that the universe is way more amazing and bizarre than we can even imagine. We think of life as we know it needs water, needs carbon, needs a certain temperature range. But what if that's just how things work here on Earth? This research makes us think bigger, What if life could exist in ways we can't even fathom? If it can exist in space, clinging to asteroids, or just floating around between stars, then the possibilities are endless.
And that's not just important for finding aliens, but for us too.
Exactly.
If we can learn from these hypothetical life forms how they handle extreme environments, how they recycle everything, how they deal with radiation, we could use that to create truly self-sustaining habitats for humans.
Imagine space habitats that aren't just metal boxes, but thriving ecosystems that grow and adapt and repair themselves, like a living organism. We could create real oases in space, not just outposts, but extensions of Earth's biosphere.
That's incredible to think about. It feels like we're right on the edge of a new era of space exploration, one where we're not just visitors, but part of a much bigger cosmic ecosystem.
And who knows, maybe someday we'll actually meet these planetless life forms, these cosmic nomads, and learn from them firsthand. What survival secrets do they have? What kind of adaptations have they developed? What kind of crazy biochemistry do they use?
It's both humbling and inspiring to think that we might not be alone in the universe, and that life could be so much more diverse and resilient than we ever imagined.
So keep looking up at the stars, everyone. Keep asking questions. Keep wondering. The universe is full of surprises, and the next big discovery could be right around the corner.
This has been an absolutely mind-blowing deep dive. I can't wait to see what other amazing things we uncover together. Till next time, keep exploring.